Hi, my name is Daniel Clark, and today on 08/03/2025, I'm going to be conducting assignment 3 for FTH 223, so please sit back and enjoy this lesson. Okay, so the first thing you see, my workspace is free and clear of any live ammunition, so is this SRA USA B6. As the slides lock to the rear, you can see into the chamber. I do not have any live ammunition currently around me in my workspace. I just have my go and no-go gauges. So the first thing for this assignment, what I needed to do was do a field strip, a detailed strip of the firearm I received as part of this course and reverse engineer certain components. Well, here's the detailed strip. You might know these pictures from earlier this week. I know they got later date, but I'm use the same pictures. I literally just broke this thing down the other day. Anyway, I digress. Next part. All right, so the first thing we had to do was take the measurements on the recoil spring. I used my caliper, I used my macrometer, and I used inches and I used millimeters to get different measurements on uh, on the recoil spring guide. Um, the next part we had to do was the ejector. I did the same. As you can see, this is a left to right view and a bottom view. I'm not a very good drawer, so don't mind the sketches. I know they're a bit horrible, but I did the same thing for this part as well. As you can see, I did millimeters, inches, and I used caliber and macrometer where I could use it. If I could use it, I don't remember if I did it on this part, but as you can see, I did the drawing and I did my measurements. Uh, Thirdly, we had to do the firing pin. As you can see, my drawing's not that great, but I did my best. I did the same on this. I used my caliber, and I did millimeters and inches, so I had different variations of measurements for these parts. Okay, so next, what I gotta do is the actual drafting of the component should be done off camera. However, show your hand drawings. Just did that. So, part two, the necessary skills. In your edited video, articulate why the skill developments and demonstrate in part one are important for a gunsmith to understand. In your edited video, explain and describe when these skills are needed. All right, why these skills matter. Part one. I performed a detailed strip of my SAR USA B6 and created dimensional hand drawings of the recoil spring guide, ejector, firing pin. These skills are foundational for gunsmiths because they build mechanical fluency. Understanding how these components function with the cycle of operations allows me to diagnose malfunctions with precision. For example, knowing the geometry, the wear points of the firing pin helps me identify light strikes and ignition failures. The drawing process also reinforces the ability to measure parts accurately and communicate technical details. Whether I'm fabricating a replacement, evaluating supplier quality, or teaching others about different parts. When would these skills be meet? When would these skills be needed? You may ask. Sorry, my French. Apparently, I can't speak English today either. These skills come in play in several key situations. First, during troubleshooting, if the firearm fails to eject or misfire, I can isolate the issue by referencing my knowledge of the ejector or firing pin dimensions. Second, in restoration or repair work, especially with vintage or custom firearms where parts aren't uh, rela- readily available. Like I said, I can't speak English, so pardon. My ability to reverse engineer and measure components allows me to recreate and modify parts safely. Third, in quality assurance, whether I'm inspecting new parts or verifying tolerances, these skills ensure reliability and safety as well. And finally, in instructional settings, clear drawings and explanations help me support others in their learning journey, which aligned with my long-term goals of mentorship in this field eventually. So next, we're going to move on to, in addition to the video and following the guidance you received in the lecture, demonstrate how to properly check headspace and timing in your provided firearm and articulate understanding why these measurements are important. So I did not see anywhere where in the lecture material, I mean, correct me if I'm wrong, where it showed to properly headspace and time this weapon. So I'm just going to do it based off of what I think is the best way to do it. It's probably wrong, but like I said, I didn't see anywhere in the lecture material that told me to how to headspace and time anything. That's just my only complaint. So what I'm going to do is first take my no-go gauge here, and I'm going to go ahead and then drop that into the chamber. As you can see, got that no-go gauge in there. Then I'm just going to take it off the safe and let that bolt forward. So the way I seen it is your spring guide rod here is poking out in the front with the no-go gauge. And if you rack the slide to the rear, let that fall out, and put your go gauge in. Well, maybe. Tried to put my go gauge in. Alright, there we go. And then ride that to the rear. Ride that forward again with the go gauge. As you can see, it's not pointing out the front. This is how I found to do the go and no go on this, and the easiest way to do it. The proper way I did not see in the lecture material, but this is how I found to do it. So now we're going to lock that back to the rear, put that on safe, and set that aside. Headspace check demonstration. As you can tell, and I made clear that the firearm was clear at the beginning. To check headspace, I used a set of precision gauges called no-go gauges, the field gauges. These are designed to test whether the chamber dimensions are within safe operating limits for the cartridges. First, I insert the no-go gauge into the chamber and gently close the bolt. A proper fit means the firearm can safely chamber a round. Next, I insert the no-go gauge. If the bolt closes on the gauge, it indicates excessive headspace, meaning the cartridges may not seat properly, which could lead to a misfire or case ruptures. Finally, field gauges is a good way to also determine headspace. I used if the firearm is still within max safety limits, if the bolt closes on the gauge, the firearm is unsafe to fire and requires corrective action. Why headspace matters. Understanding headspace is vital for several reasons. First, it's a safety issue. Improper headspace can cause catastrophic failures, including ruptures, ruptured cases, and out of battery dimensions. Second, it affects reliability. A firearm with poor headspace may fail to eject, misfire, or damage the brass, leading to inconsistent performance. Third, it is essential for diagnosing or repairing, whether I'm evaluating a used firearm, performing barrel work, or troubleshooting extraction issues. Headspace tells me whether the chamber geometry is contributing to the problem. And finally, it supports the long-term goal in quality assurance and supplier evaluation. By understanding headspace, I can assess whether components meet spec and ensure safety function built. Sorry for stuttering through that. This has been my presentation. Thank you for watching. We'll catch you on the next one. Peace out.